My name is Michele. Well, good afternoon. I'm working for HCL and I'm calling from Italy right now. So as somewhat anticipated, I will cover how to submit a patch to the OMEC project on GitHub briefly, and then I will walk through the current CI/CD process that we have up and running in the OMEC project at the ONF. So basically, in order to contribute to the project, you need to create a pull request to the project. There are yes. Yes. Okay, better. Okay, so there are on GitHub some documents that explain how to create a pull request. I've made a short summary with also my, let's say, preferred way that I think it's the most easy to work with, which has no problems with permissions and so on the repositories. All you need to have is an account in GitHub. So the first step that you need to take is to fork the repo of interest. So for example, in this case, we are on NGIC RTC, and you press the button fork on the right, and under your account you get a copy of the NGIC repository, which is forked from the original. After you have done that, you can clone your fork locally to your environment, computer or server where you're working. You can implement your feature, and you can push the change back to a branch on your fork. After you have done that, basically your work is now staying in the fork repository in GitHub. And what you need to do is to create a pull request from your fork to the original repo. It is a good practice that every time we make a pull request, we also open an issue in order to keep track also of what we are doing and why we are doing that, and also to give to the community an opportunity to discuss the changes that you are doing also in the issue part of GitHub. So once you are ready to make the pull request, you go to the original repository. You will see a menu with a button, new pull request. You press that, and the new menu will appear to you. And basically on this menu, you will see basically two things, which is the base repository, which means the original repository, and the branch where you are making the pull request to, and where you're coming from, which means your fork and the branch that you have uploaded to your fork. There will be other informations when you compare, such as what has changed, how many files, and so on. There will be also a menu where you can add a title for the pull request and a description, which usually is pre-filled with the commit information from the patch that you have uploaded. And as I said, if the pull request solves an issue that is tracked into the repository, you can add a keyword resolve hash and the issue number, which when the pull request is merged, will automatically also close the issue. So there is a connection between what happens in the pull request part and what happens in the issue list part. And then what you have to do is to push the create pull request button. Then what happens in the flow? Once the pull request is created, the policy that has been established at OMEC, which is currently applied, is that one of the OMEC project maintainers, each repo has a set of maintainers, will review the patch set and will mark it with a comment, OK to test. Once it's marked with this OK to test from one of the reviewers, the patch will trigger the continuous integration test. So basically, there is a plugin between Jenkins and GitHub that once the pull request is approved to be tested, will tell the Jenkins system that is running on at ONF at the following link. So if you want, you can also click the link and follow, and you will land on the ONF site where the Jenkins server is running. So this Jenkins job will be started. It will carry out a series of tests that we will walk through in the following slides, and it will score the pull request with go-no-go result. So if there is any error, the pull request will be marked as failed. If there are no errors, the pull request will be marked as all check have passed. If the Jenkins test fails, it's probably interesting to see why it failed. And if you follow the links on the right side with all checks and details, you will be redirected to the Jenkins server, where there will be basically the console output of all the processes that have been run, and also the possibility to inspect the logs that have been produced by the different DNFs that have been shown previously. So now, if the pull request is tested successfully, then the maintainers have to go back and decide to whether to merge or not the pull request. So the merging is blocked until a maintainer arrives and perform the merge into the repository. So this is basically a quick walkthrough. As I said, on GitHub, the process is quite documented. So for any reference, I encourage to look into GitHub. And if you have questions, you can always contact us on Slack channels and the ONF contacts for the OMEC project, and someone will come back to you to support in your work. Now, let's have a walkthrough into the continuous integration process. That means the part that is triggered once the pull request is marked as OK to be tested. Basically, we have shown that there are 8 repos. The repos where this continuous integration process is established is basically on the functional part of the project, which means the component under the C3PO, NGIC, RTC, and OpenMME repositories. So the other repositories, such as the traffic gen or the OSS utils, for at the time being, they are not screened by the continuous integration. So if any of these repos receive a pull request, the Jenkins job starts, and this Jenkins job is called OMEC underscore, the name of the repository underscore combined, and will coordinate basically the actions that you see on the right. That is the first step where these VNFs are installed. This install phase can be carried out in parallel because, as we have seen, they are different and independent components. So in order to minimize the test lead time, we can carry out those in parallel on different machines. And so for processes are triggered. These 4 processes will basically delete everything that is in the working area of the Jenkins account on these machines, clone from scratch the repositories from GitHub, and carry out the necessary compilations and configurations for these different VNFs. After this first step is completed, 2 test cases, 2 traffic test cases will be executed. They are called OMEC_TC1 and OMEC_TC2, and they basically test the system in 2 configurations of those that Somnat has described before. So there is a first test case that will cover the configuration where the communication between data plane and control plane happens through the CMQ messaging system, and the interfaces are handled through the KNI part. And the second test case is that where the communication between control plane and data plane is carried over the UDP protocol, as Somnat described before, and the interfaces are managed by the static ARP protocol. And basically, one thing to note is the following. All the repos will be cloned on master, except the repo that has received the pull request. And in that case, the branch corresponding to that pull request number will be taken out. Then moving forward, a few notes on the CI/CD environment and some comments. The resources for the CI/CD job, which means the Jenkins scripts that are needed, they are themselves hosted in one of the repositories under the GitHub main page. So they are open and everybody can look into them and improve them. Instead, the VNF configuration for the CI/CD environment is stored into the OMEC VNFs repos. There is a special directory called .ci where all the information such as IP addresses, MAC addresses, or whatever is needed is stored in the different repos, because we wanted to decouple, let's say, the logic from the configuration itself of the VNFs. If you want to contribute to the Jenkins scripts, right now they are scripted using both the declarative and the scripted pipeline syntax. The ONF goal is to transition to have only declarative pipeline. So if someone is willing, this is one task that could be picked. Another thing to comment, which should basically be understood by now, is that if there is a patch or a feature that involves 2 repositories at the same time, so let's say a feature that affects both the HSS and the OpenMME, for example, this is not currently covered by this workflow. So this kind of features, they need to be handled on a case-by-case and be coordinated with the maintainers of the 2 repositories, because the GitHub plugins is able to keep track only of its own repository, so there is no coordination between what happens in one repository and what happens in another repository. So if there is any feature of this kind, the best thing is to discuss this with the OMEC maintainers of the repos affected and see the way forward. So one patch, for example, will have to be approved, let's say, blindly, and the second one will be the one that will make the complete test of the 2. Okay, another thing to note is that since HSS and the SGX part are both hosted into the C3PO repo, when you submit a pull request for either HSS or SGX, basically this will be considered as one modification to the C3PO repo, regardless of what we are touching in the two DNFs. Another important information is how the cluster of machines is set up. Currently, there is a cluster which is running in Intel VLabs with plans to migrate to ONF in the coming future. The way they are organized is as follows. There are these 5 VNFs which are running as virtual machines on a server. Then there is the SGX, which is running on bare metal. And then there is the load tester server, which is also running on bare metal. There is no specific reason why these 5 functions need to run on VM machines instead of bare metal, but is to optimize the use of the hardware in the cluster and to minimize the amount of servers that we need to run this. Another thing to note is that currently there is an activity in process where we are replacing the Polaris load tester that was, for example, used in the video that we have seen with an NG40 test system. So right now, the CI/CD process is on hold, which means that if you submit a pull request, this flow will not run or will run with an error because we are in the middle of this migration and we are reusing the same servers. Obviously, for the CI/CD to be performed, we are assuming that the virtual machines are up and running, that the database of the user is also up and running, and there's the information that are needed for running the test profiles that will trigger. And there is a connectivity among the virtual machines. There is basically no reason why these things shouldn't be as they are supposed to be. But it might happen in some cases that there are glitches. So if there is something like that, if you contact us, we will do our best to put the environment back as it should be. I'm mentioning the names of the virtual machines and the name of the servers and so on, because when you will look at the console output and the logs, you will see commands that are referencing to these names. So being familiar with the names of the machines and so on will help in reading out the outcome of the Jenkins process. Another thing to note is that everything that is running on the servers in terms of processes is basically killed before a new Jenkins job starts. So there is nothing left as a, let's say, current state. Everything is deleted, everything is killed, and we start from scratch every time to make sure that we don't have a stateful environment, but instead a stateless environment. As I anticipated before, and also as basically we have seen in the video, the 2 tests that are carried out are basically following the profile that we have seen. There are 32,000 UEs that are attached and detached and 250 transactions per second with a data rate of 35,000 kilobit per second in the 2 configurations that we have now discussed quite in details. We will see now some screenshots. There is a job stage that is called Polaris test, which is based on the existing Polaris report. This will be updated as soon as the NG40 load tester will be up and running, and also new capabilities will be added in terms of showing up the results. One thing to notice, and if someone wants to modify these parts, is that as has been described before, The data plane needs to encrypt information for the SGX dealer to work by using keys. The CI/CD needs to know this information, so this information are parsed from the configuration files and so on. So if there is a patch that touches the specific configuration files where the keys are, the informations are stored, we need to be notified because we need to change the logic that look into these files to display the test results that I will show later on. Another thing to notice is that it might happen that two developers, they submit a pull request basically at the same time, being in different part of the world. The Jenkins server is able to understand that a new job wants to be triggered while one is currently running. So the latest job will be parked in a queue, waiting for the first one to be completed. At the end of the first one, the second one will start. So there is no conflict between pull requests submitted concurrently on GitHub. Then now we go through some more details. Let me check okay, we have a few more minutes. So how to investigate if something goes wrong, or how to check what's okay. All the results are visible and browsable through the web server where the Jenkins is running, with different kind of interfaces, the standard interface or other plugin interfaces. And you will be able to see the console outputs that all the jobs that we have seen in the videos for the 12 BNFs are generating, and also the information provided by the execution of the install script and the execution scripts themselves. So there is quite an amount of logging, which will be captured, basically the information that you've seen on the screen before. So hopefully this is helpful in identifying why something is not working. This is the overall dashboard of all the jobs that are running at OMEC. So when you go on the Jenkins server, you will land in the main page. If you click the OMEC tab, you will see which are the jobs that are running specifically for OMEC. There are many of them. As I explained before, only those called combine are the entry points in this list. But these combined jobs, they will sequentially call all the others. So all these jobs are interesting to inspect in case of problems. This dashboard will show also the status of the jobs. The blue ones are the okay, the red ones are the failed, and then the icons will say the F of the job. Something failing very often, something succeeding often. So now let's see a flow from the beginning to the end very quickly. So a pull request has been submitted in this case to the repository NGI RTC. The ID of the pull request is the number 85. This information will help in following the flows. There is information on the commit, and in this case, all the checks have passed. If you click or show all checks here in the bottom, you will go to basically the combined job that was triggered. So job number 204 was triggered. And if you look at the console output of this combined job, you will see that basically all these tasks that I have mentioned before have been executed with a reference to a specific instance of each and every item. So basically, this screen is a summary of what has been run by Jenkins for this specific pull request. And if you want to inspect each step, you can click the link and you will be redirected to the different pages for the different jobs. In this page, there is also the final result, which is in this case is a success. There are also information on the commit numbers, which are useful to see that you are actually viewing the tests related to the pull request that you have triggered. If you remember, it was pull request 85 with a commit ID. Now, quickly, a quick overview of what you will see also from the graphical point of view. There is a dashboard, a graphical dashboard that will show all the steps and also statistics of how long it takes to carry out the different parts. As I said, the installed parts are parallel, so you don't have to add up these times, but you just take the maximum of them. So in this case, it's about 6 minutes, 6-7 minutes for the installation phase. And then the two test cases are done in series. So there will be another 10 minutes plus 10 minutes to be added. So the overall process takes about 25-30 minutes to be run. So in this case, everything is successful, everything is green. If you want to go into details, for example, if you want to see the results of the NGIC-RTC install task, you have the artifacts here on the right that you can look into, and you can see the standard error, standard log, standard out logs for both CP and DPs, for example. This can be done for all the different VNFs. I'm showing just this one as an example, but the others are basically the same footprint of information and look and feel. Also here you have a reference to what has been cloned from a NGIC RTC. So you will have a confirmation that you're actually looking at the branch related to the pull request 85 and that you are applying the commit that you were expecting. Then we go to the, once the installation is completed, we go to the test case related to the traffic parts. What will happen here is that all the different VNFs that we have seen in the video started manually. They are started by the Jenkins task in the order that basically we have seen before. There is a step here which is to make, again, the control plane and data plane, because we need to change the configuration from one task to the other. So we are running SMQ KNI first, and then we have to recompile to apply the UDP ARP configuration. So everything is started. There is a step here called check processes, which will scan all the VNFs to see that the expected processes are up and running. If some process is missing in action, a failure is triggered and the test will stop. So it's a sanity check that all the startup phase of all the different VNFs has been executed. Then there is test traffic, which is basically the 32,000 attach traffic transmission and detach. And then there is a sanity check on the fact that the DP and the SGX components, they are talking about the same set of records that Somnath has shown in the slides. The outcome of this test job is basically what we have seen on the console. There is the outcome of the load tester. So you see 32,000 attach, detach, and so on. And you see also check here on this comparison of the identity file names that the DP is producing and the identity file name that the CDR is consuming from the data plane. This is not going into the details of the single records, because as we have seen, that wouldn't be possible, but it is at least a sanity check that data plane and CDR, they are basically talking about the same object. So nothing went wrong in the configuration of the keys and the encryptions in the SGX part. Okay, so this was when everything goes well. Now a very brief view on what if something goes wrong. Instead of seeing everything green, you will see that red will start to appear. And basically you will see where the failure has happened. So in this case, as an example, something went wrong with the installation of the NGIC RTC component. And you will see a big red square. And you also see that there is nothing executed basically from the traffic perspective, because the duration is very, very small. So it's just a few milliseconds of stuff. So something happened here in the NGIC, and the complete build through a failure as a result. So this is basically the pull request that we are looking at. Checks have failed. You click the link, you go and inspect. You will see that it has failed into the NGIC RTC. So you have both a textual and a visual clue that something went wrong here. And if you look at the console, since the script is executing make clean, make restore, etc., you will also see what step failed in the building process. So in this case, there was something wrong with the targets and so on during the compilation. If this is not enough, you can always click the links to the standard out and standard there, and you will see additional information. One last thing, as I said before, CI/CD is currently on hold to allow this migration. This doesn't mean that the pull request will not trigger jobs, but the jobs will basically fail during the test case execution, and they will fail very quickly because the Polaris server right now is not responding. So if you see something like this, with test case 1 failing after 30 seconds, it is because we are in this migration phase. So right now you will see this. So that's basically it. I hope that I managed to stay into the schedule. So now it's time for the Q&A that someone mentioned before. So I leave you the screen and the control. You can take it back. Okay. Yes, this was a decision that the ONF has taken, and I think it's related to the capabilities on NG40 in terms of traffic profiles that are available for the test.
What is capability discrepancy or lacking thereof that made you want to do the switch from Polaris load test to NG40? Thanks.
So Nat, can you here?
Apart from the capabilities which we can discuss later, I mean, we can discuss offline as well. But I think there was some licensing discrepancy as well, and some license expiration.
So Nat, can you move near the microphone?
I am nearest to the microphone. I can't get closer to this. But yeah, I mean, basically, it would be great if Christian can answer that question. Christian, are you there in the room?
Says you said Christian not.
Oh, I believe not. Okay, that's fine. So yeah, basically, there were some discrepancies. Not discrepancy, I would say there were some differences between the test characteristics that we expected Polaris to support versus what it could support based on the licenses that we currently have. when we had discussion with the G40, basically they were able to satisfy those requirements for our ONF setup. So that's the primary reason. There are other reasons as well, which we can discuss on this meeting.
Any other questions? Okay, before we have a break, let's review today's schedule. So from after the break, we will have the real hands-on for the OMEC. But for each person to hands on, we need the UI, and not in the morning we just like SH log in the server. In this session, we also need the UI. So here we need the cloud LAMP account. Everybody needs to register account.
Yeah, so let's continue. So basically, next tutorial is going to be hands-on tutorial, and for that everyone needs Cloud Lab account. If you don't have one, we'll just tell you the instruction. Please create the account and raise a request to get access to the project. So we request you to do that before you go for a break, so that we can approve your access to the project.